Hello students, my name is Shashank Shekhar. So let us start with the first lecture of the chapter, that is some basic concepts of chemistry. So today we will talk about mole concept here. Okay. So why is this mole concept introduced and what is this mole concept and how it is implied? We will talk all about this. So let us first talk about why was this mole concept introduced? What was the reason for introducing this mole concept? Say students, when we talk about atoms and molecules, so they are extremely small in size, right? Now, if you take 1 gram of any substance, that would contain an enormous amount of molecule or atom or say any entity that it is being composed of. Now, to deal with it becomes very difficult. So, what was done? There was a kind of counting number introduced to define this counting. Okay, so to make this handling easier, and that method was mole. Now, mole is not just a abrupt thing that is taken from some random number. It is being defined on some basis, and that basis is C12 carbon atom. Okay. So it was said that 1/12 of the mass of a carbon 12 atom. So what they did is that they took a carbon C12 atom, and with the help of spectroscopy, they calculated the mass of that and divided that mass by 12, means taken that 1/12 of it, and that much amount was assigned as 1 mole. Okay, now relative to that, we calculate our mole for each and every given atom. Now some of you have a great confusion that where should be mole applied. Okay, so where should be this counting applied? So talking about this this application, so it can be implied anywhere depending upon the utility, that whether that thing is applicable there or not. So say if we are using 1 dozen for banana, it is not fixed that we can use it only for banana. We can use 1 dozen for apple also. There is no such compulsions to use it for banana only. Or we are saying score for 20 items. See, so score can be of anything. Say score can be of children, score can be of people, score can be of any fruit. So score of anything will contain how many items? Only 20 items. Similarly, we have gross for 144 items. So similarly, this mole is also applicable to any entity. So generally we use this for atoms, molecules and ions, because for them this value, that is 6.022 into 10 to the power 23, that is the number of constituents present in 1 mole. It is good for that, atoms and ions and all. We do not have any use in the case of physical world, because that much amount is never used here. Okay, so we can say that mole is nothing but a way of counting, a easy way of counting the entities at microscopic level, say for atoms, molecules, particles, electrons, ion. So we can have any entity. Say we can have 1 mole of electron. So how much electron will be there in 1 mole? 6.022 into 10 to the power 23 electrons. Similarly, we can have 1 mole of atoms, in which how many atoms will be there? 6.022 into 10 to the power 23 atoms. 1 mole of molecules. So did you get my point? What I'm trying to make here is that uh, by defining it 1 mole, we mean that we have 6.022 into 10 to the power 23 amount of that given entity. Now this is a mole is can be said as the counting unit in SI system, and this is the 7th base unit. So we have 7 base units, in which we have candela for intensity, a meter for speed, and sorry, meter for distance, second for time. So similarly we have mole for counting, and this is the 7th base unit. Clear? Now, as I have said earlier, that the mole symbol mole is the SI unit is the amount of substance, and 1 mole of that contain exactly this much amount of elementary entity. Now this number is fixed numerical value and it is called as Avogadro constant. So this Na is equals to 6.022 into 10 to the power 23 unit per mole. So that can be for any unit, and the amount, and it is represented by Na. Now elementary entity may be an atom, molecule, ion, and any other particle. It may be emphasized that a mole of substance will always contain the same number of entity no matter about which we are talking about. So again, this statement is made here, and I think this is the most important statement throughout the mole concept. And you can say that for any entity it will be always this much amount. Now, as I have told, the basic definition of 1 mole is, I would say the scientific definition of 1 mole is, it is the mass of a 1/12 of the mass of a carbon 12 atom. So here it is written. So we have done this, say we say that the mass of a carbon 12 atom is this much, okay, and we have taken 1/12 of it. So by 12 we have decided divided by 12, and then we got this thing, okay. So if you want it, you can write it in this way also. So we generally use the scientific notation. So again, that illustration is given that if we have 1 mole of hydrogen atom, then that would contain 6.022 into 10 to the power 23 atoms of hydrogen. If we have 1 mole of water molecule, then we will have 6.022 into 10 to the power 23 water molecules. If we have 1 mole of sodium chloride, then we will have 6.022 into 10 to the power 23 formula units of sodium chloride. Why it is not written as molecule and it is written formula units? So this should be very clear that NaCl is an ion. It will never be present as molecule. Na and Cl will present an ion as an formula unit. Okay, so that is a way of representing this entity which is formed by combining Na and Cl, because they are not molecules, so they are formula units. So we have defined the mole. So the molar mass in grams is numerically equal to the atomic mass in U. So if I say the mass of 1 mole of a substance is of a gram is called its molar mass, and if you write it in terms of say U, then it will be said as atomic mass. Okay, so the molar mass of water is this much gram per mole. So what does it mean? That this much amount of water, this gram of water, 18.02 gram of water will contain how many molecules of water? It will contain 6.022 into 10 to the power 23 molecules of water. Molar mass of sodium chloride is this much, which means that it will contain, this mass will contain 6.022 into 10 to the power 23 molecules of sodium chloride, that is NaCl. Now how we have calculated this 58.5 and 18.02? So for that we have calculated the atomic mass of H2O, H and oxygen, and added according to their coefficient, and then we have found this. Now how is the atomic mass calculated? So it is calculated in relation to this, say our carbon 12 atom. So we do not need to carry out the say our counting again and again, or calculation again and again. So you should at least remember 15 to 20 first 15 to 20 members atomic mass along with their atomic number. So hydrogen has an atomic mass of 1 and oxygen has an atomic mass of 16. Okay, so there are two hydrogen, so 1 into 2 that is equals to 2, and 16 into 1 that is 16. That would give us total of 18. So it is approximately 18. If you write the accurate one, it will be 18.022. So similarly you can calculate it for sodium chloride. So this is the formula unit mass of this sodium chloride. How we can calculate it? So sodium has a mass of 11 Okay, sorry, 23, and your chlorine has an atomic mass of 35.5. That would give us 58.5 gram per mole. Now let us do some questions on mole concept. The first question says that we have to calculate the mass of 12.044 into 10 to the power 23 oxygen atoms. So from the definition of this 1 mole, we know that from the molar mass that the molar mass of oxygen is, so molar mass, or we can say atomic mass, molar mass of oxygen is equals to 16 gram per mole, and we know that means it is the mass of 1 mole of oxygen, and we know that 1 mole contains 6.022 into 10 to the power 23 atoms of oxygen. We know this thing. Now what we have to calculate? We have to calculate the mass of this much number of atoms. How you will calculate? So if this is the mass of 16 gram, so what is the weight of one atom? So this is the one atom will weigh how much? One atom will weigh 16 gram by 6.022 into 10 to the power 23. So this is gram per mole, and this is per mole. So that is the mass of one atom. What is the mass of this much atom? That is 12.044. So for this, that is 12.044 into 10 to the power 23 atoms will weigh 16 by 6.022 into 10 to the power 23 multiplied by, so if I erase it, let me erase this part, that is multiplied by 12.044 into 10 to the power 23. So this and this gets cancelled out. So it is nothing but 2 multiplied by this, that would give us 32 grams. So the weight of this much mass of this much number of oxygen atom is 32 grams. Next is, what is the number of, we will just see the solutions. So it has simply use this thing. It has first calculated the number of moles, and then it has multiplied the number of moles by atomic mass to get the mass. So you can do this in this way also. Next is, how many moles is there in this much atoms of helium? We have to calculate the moles in this much atoms of helium. So we know that 1 mole is containing 6.022 into 10 to the power 23 atoms of helium. We know this. So one atom will contain how much mole? One atom will contain 1 by 6.022 into 10 to the power 23 mole. Therefore, 12.044 atoms will contain how many moles? 1 by 6.022 into 10 to the power 23. It is multiplied by 12.044 into 10 to the power 23. That would give us 2. So 2 moles are there in this much number of atoms. It is written same. So we know that this much atoms are present in 1 mole. Therefore, number of atoms present in 11.044 will be, so this will be not 11, this will be 12. So 12.044 by 6.022, 23 cancelled out, and we get 2 moles of helium atom. Next is, an atom of some element Y weighs this much. Calculate the number of gram atoms in 40 kg of it. So what it is written, that the atom of some element Y means the mass of one atom is given. The mass of one atom is given as 6.644 into 10 to the power minus 23. Okay, so one mass of 1 mole of atom will be, mass of 1 mole of atom will be how much? 6.644 into 10 to the power minus 23 is multiplied by 6.022 into 10 to the power 23. So that would be the mass of 1 mole of atom. Clear? Means in 1 gram atom, or we can also say that in 1 gram atoms, this much is present. Okay, this is the gram atomic mass. So for 40 kg, it would be 40 by this value. Clear? So first we have calculated the atomic mass, that is 40 gram. That is the atomic mass. So mass of 1 mole of atom is the atomic mass. So that would be 40 by 40. So we have done this only. Here you can see this. So we have divided this 4 by this much. So this multiplied by this gives us 440 only. So that brings us to 1000. So since that was in kg, so first we have converted this 40 into gram by multiplying by 1000. Last question. What does this last question says? So how many molecules of water are there in 54 gram of H2O? So we have calculated the number of molecules in 54 gram. First we have to calculate what? The molar mass of water. What is the molar mass of water? So if you know the formula, the atomic mass of hydrogen is 1. Okay. So therefore we will multiply it by 2 since 2 hydrogens are present, and the atomic mass of oxygen is 16. Therefore 16 multiplied by 1, that would bring us to 18. So in 18 grams, we know that 18 grams contain 1 mole. Okay, so that would give us Na number of atoms, Na number of molecules, number of H2O molecule. And what is that Na number? It is 6.022 into 10 to the power 23 number of H2O molecule. So 18 gram contains this much number of atoms. Now 1 gram will contain 6.022 into 23 by 18 number of H2O molecules. Hence 54 will contain 54 gram will contain 6.022 into 10 to the power 23, that is divided multiplied by 54. This is 18 3 is 54. If we will solve it, we will give it will give us 18.044 multiplied by 10 to the power 23 atoms, sorry, molecules of H2O. If we further say multiply it or bring it in proper scientific notation, we have to move the decimal one place here. So power will be increased by 1, that is 10 to the power 23 molecules of H2O. So that brings to the solution. First, what we have done, we have calculated the molar mass of H2O, that is mass of 2 hydrogens plus mass of atomic mass of 1 oxygen. That brings us to 18 gram per mole. We should be clear about this unit also. So when you to calculate the number of moles, so that is given mass by molar mass. So given mass is 18 grams and the molar mass is 80. So given mass is 54 gram and the molar mass is 18. So mass is represented in grams and molar mass is represented in gram per mole. So that would give us mole. So the unit is 3 mole. Now 1 mole contains this much number of atoms. So 3 moles will contain 18.066. Or we can write it in more proper scientific notation as this much. Clear? So one important formula that is used to and fro is that number of moles, and I mentioned it earlier also, that number of moles is equals to given mass by molar mass. So we have used this in each and every question, if you notice, almost in each and every question. So here we have used it. Okay, given mass by atomic mass. Okay, or if you talk about this question also, we have used this given mass, number of moles. Okay, so with this I end my lecture. Thank you.